Good day, everyone. Welcome to Direct Stars. Our subject for today is physics, while our topic is alpha, beta, and gamma radiation. Yes, aim of today's lesson is for you to understand the difference between alpha, beta, and gamma radiation. Objective of the lesson is for you to understand what a radioactive substance is, the types of radiation, and different types of radiation emitted by radioactive sources. But first, we need to understand what radiation is. Radiation can be defined as energy that moves in space. So how energy moves in space is what we call radiation. So how do we discover alpha, beta, and gamma radiation? Firstly, now we go with this. The first is starts from a key discovery. This key discovery in 1896, a French physicist named Henri Becquerel. Yes, he discovered a mysterious image of a key on a photographic film he developed. So from there, now remember that there is one mysterious image showing on that key. So he's just wondering what can cause that. So you remember that the film had been in a drawer under a key, and under this key there is what we call a packet of uranium salt. Yes, we know uranium is an element that releases radiation that allows the energy, okay, that allows energy to move in space. So the uranium salt must have sent out some of the radiation that passed through the paper, which is the film wrapper, but not through the metal. So he was just wondering. So then it called Marie Curie to investigate. So Marie Curie investigates and says that this salt emitted radiation all the time. So she used the word radioactive. So radioactivity to describe the strange of the new property of uranium. So she and her husband, Piri, did more research of this new branch of science, which is radioactivity. Now they discovered that we have another new radioactive element, and they named it polonium. Yes, we all know how polonium is an element that has high energy and radioactivity. So they name it polonium after Marie's native country, which is Poland. But that's not all. But that's the first steps in which we know what alpha and beta particle or beta radiation is. So since then we go with inside the atom. We still have a question that what really stops this radiation? Now, what can stop alpha particle, beta, and gamma radiation? So then we have this physicist, Ernest Rutherford. It carried out tests to answer the question about a century ago. So he put different materials between the radioactive substance and a detector. So he discovered two types of radiation there. And the first radiation is alpha, which is the alpha radiation, and the second one is beta, that's beta radiation. How does he discover this? He discovered this radiation because alpha radiation was stopped by paper. I mean, ordinary paper. Alpha radiation was just stopped by paper. But there is another radiation that penetrates through this paper, and that is beta radiation. It went through the paper, but we don't know what stopped beta radiation then. But some years ago, then we denote what we call gamma radiation. And since then, we can see that gamma radiation is more penetrating than beta radiation. So we need to understand alpha, beta, and gamma radiation and what is their penetration range. That brings us to this image here. Alpha radiation. So we have gamma radiation here. So alpha radiation can be stopped by ordinary paper. Yes, it can be stopped by ordinary paper, but beta radiation can pass through a paper, but it can be stopped by just a little millimeter of aluminum. While a gamma radiation can pass through the paper, the aluminum, but it will be stopped by a lead. So these are the radiation, alpha, beta, and gamma. Though this radiation, yes, they allows energy to move in space. We have these different types of it, but they allows energy to move in space. So when energy moves in space, the alpha radiation on its own can be stopped by ordinary paper when this energy are moving in space. But beta radiation can be stopped by aluminum when energy moves in space, while gamma radiation can be stopped by lead when energy moves in space. So we have a table to simplify these three types of radiation. Now we have alpha. Alpha has 2 protons and 2 neutrons. Alpha, it has 2 protons and 2 neutrons. It's just like a mass number and a proton number. That is alpha. And it has the charge of +2. Okay, range in here is just a few centimeters. it can be stopped by paper and the ionization is very high. While beta has electron negative charge, that's -1, that's the charge. Range in here is few tenths seconds of centimeter, while it can be stopped by a few millimeter aluminum and the ionization is just medium. But gamma radiation, gamma radiation is coming from electromagnetic wave. Electromagnetic wave is those radio wave, infrared, ultraviolet, visible light, X-ray, and gamma. So gamma is coming from electromagnetic wave. Its charge is 0. Its range in air is infinity, so it can be anywhere, while reduced by few millimeter lead. Okay, and their ionization is very low. So these are the 3 types of radiation. Okay, so that will be the end of today's class. So in our next class, we move to alpha radiation. We'll explain more about alpha radiation. So thank you for watching. Please don't forget to click on the subscribe button. See you in our next class. Bye.